Hello, and welcome to a new edition of H.E.L Explains with your host, Dr. Mario Torres Rodrigo. And today, we're going to be talking about bioplastics and climate change, and all of this is going to be just riding the coattails of a great webinar we had a couple of weeks ago presented by James Egan, in which he was talking about his research and how CO2 can be used to produce bioplastics. And he posed these questions. Are bioplastic the solution for all our climate change derived problems? This is what we're going to be trying to answer in this webinar. So, first of all, let's talk about plastics and how much plastic we need as humanity in order to cover our needs. We need 460 million tons of plastic every year. That is a huge amount of plastic. And to give you an idea of how big this number is, if we put all humans together, the weight of the total humanity is going to be 390 million tons. So it is less than the amount of plastics that we need. But what is the problem with plastics? Well, plastics are designed to be recalcitrant. This means that they're not going to degrade over time, they're going to be stable. The problem with this is that once that we had our plastics and we dispose them, they're going to be accumulating over time and it's going to have a polluting and harmful effect. And also, one of the main problems is that traditional plastics are normally made out of fossil fuels such as petroleum. And the amount that we need is going to be so big that by 2050, 15% of all the total carbon budget will derive from the production of plastics. So, what could be the solution for this huge problem? Well, first of all, we try to avoid the use of single-use plastics. Single-use plastics are produced and then they are disposed and they cannot be recycled. They derive from fossil fuels, as we mentioned, and the process of producing plastic is very high energy consuming. Another possible solution is recycling. Recycling, it means using plastic that have been used once and putting through a process that is going to generate new plastics. Massive bonus because we can avoid the production of greenhouse gases that we get from new plastic production. And also, one of the main issues that producing plastics generate is the release of certain pollutants such as nitrogen and phosphorus that act as fertilizers for example, algae that generate algal blooms and they can produce a lot of ecological problems. In terms of recycling, we have processes such as mechanical or chemical recycling that are going to have differences, but they have the same objective, producing new plastics. But recycling is not the perfect solution because there is always a mass loss during this production, which means that in order to cover for our needs, we will need to produce more plastics. This is going to bring us to our $1 million question. Are plant-based plastics the solution to our problems? To answer this question, we need to understand certain things first. So first of all, what are plastics? Plastics are polymers. This means they are a chain of chemicals that are linked through chemical bonds that derive from small molecules called monomers. And one of these monomers that is very central to plastic is methanol. Methanol can be produced by a number of ways, which is great. So, for example, it can be derived from industry gas waste, in which CO2 and carbon monoxide are combined with hydrogen to produce this methanol. It can also derive from water hydrolysis, in which the molecule of water, H2O, gets broken down to produce hydrogen gas and oxygen gas that then can be combined with CO2 to produce this methanol. And also, it can derive from biomass. Biomass can be gasified or it can be combusted in order to generate CO2 and carbon monoxide that then can be combined with hydrogen in order to produce this methanol. But it also has certain downsides. I mean, it is a very easy to produce source, but then the problem is that in order to produce it, it requires extensive land use. This means that we have to seed and plant a lot of these plants over a large extension of land that is going to have impacts on the ecosystem. So, for example, it's going to reduce the biosphere diversity and the integrity of the biosphere. But also, plants require certain nutrients such as nitrogen and phosphorus that we mentioned that can be pollutants. And also, one of the problems that they have is that these molecules are very susceptible to runoff. So, the problem is we are going to have our land, we are going to add these fertilizers, and then we are going to have some rain that is going to just clean this nitrogen and phosphorus, and it's going to move it downstream to water bodies where it can be quite damaging. But it has a massive bonus as well. It reduces the amount of greenhouse gas that we are emitting, and also is going to help to just withdraw some of the CO2 from the atmosphere, helping to solve the problem with climate change. So we have all of these potential approaches, but we don't really have a solution for our problem. Well, actually, the solution would be integrating these different approaches in a way that we increase the upside of the approaches and we try to mitigate the downside of the different ones. So, for example, we can have that recycling is very good, it's going to generate and regenerate new plastics from old plastic, but we are going to have of matter that is going to go missing. In that case, what we can have is bio-derived plastics that are going to be producing new plastic that we can incorporate into the plastic chain. So the aim of this approach is going to be balancing a bit of all of these potential problems that we have from plastic production, such as greenhouse gas production, biogeochemical flows with the nitrogen and phosphorus that we mentioned, and also keeping the biosphere integrity without having to take too much land from natural spaces. But other potential tools we can use for this plastic production? The answer is yes. We can also use the power of chemical synthesis. And we have mentioned that methanol, it is a key central molecule in all of these plastic production and polymerization processes, but it is not the only molecule that we can use for plastic production. For example, CO2 can play a very important role in this in what we call copolymerization. What is this? Copolymerization means the use of more than one monomer in the process of generating these polymers that are going to be the backbone of our plastics. And what are the advantages of using molecules such as CO2? Well, obviously, CO2 is one of the main problems that we have with climate change because it accumulates in the atmosphere and it increases global warming. But if we can just remove it from the atmosphere and capture it in molecules that are of interest for us, such as plastic, it is a win-win. But also, chemical synthesis relies a lot on catalysis, and we are tirelessly trying to identify new catalysis that are going to be able to produce these molecules that we need, reducing expenses, reducing times, reducing the energy that we need to produce these plastics. So chemical synthesis is going to be playing a massive role in the near future for plastic production, for sustainable plastic production. And this is all from me. My name is Dr. Mario Torres Rodrigo, and I am the applications leader here at H.E.L. I would recommend you to go and check our webinar section if you're interested in the topic that we have discussed on this H.E.L Explains video, because you can find the James Egan webinar in which he actually gives a lot of more insight into the issue of plastics, CO2, and climate change. That's all from me. I hope that you enjoyed this video, and if you have any questions or any comments, please just come back to us and talk to us. Thank you very much.